Assalamualaikum and good day everyone. My name is Muhammad Ismail Anuar bin Muhammad Sufian. Today I am going to present my final year project 2 and the topic is physico-mechanical properties of clay reinforced plastic waste concrete aggregates, and I am supervised by Associate Professor Dr. NORAIHAM Binti MOHAMMAD. These are the contents that I am going to present today. Firstly is the introduction. Background: environmental concerns of natural concrete aggregates. Because the growing demand for concrete aggregates, the resources will decrease over time by Rahman in 2009. Reprocessing waste plastic material as the aggregate is an environmentally viable alternative. For the properties enhancement, increase the physical properties of the plastic waste aggregate, such as the density and specific gravity. Secondly, improve the mechanical properties of plastic waste aggregate, such as the hardness and tensile properties. For the problem statement, firstly, plastic waste is currently rising as a global issue. Plastic cannot be easily wholly recycled. Sharma 2016 said massive amounts of plastic waste require vast stretches of land for storage. Secondly, however, the strength of concrete produced using plastic waste aggregates is far lower than that produced by natural aggregates. It is reported to be due to limited surface interaction. Shen 2012 said kaolin clay increases the spaces between the sand particles and suspends the aggregates inside the paste when used to form a paste. The objectives. The first one is to compare the physical and mechanical properties of the virgin polypropylene, recycled polypropylene, and PP composites. Secondly, to evaluate the morphological, compositional, and structural characteristics of the virgin polypropylene, recycled polypropylene, and PP composites. For the scope, based on Objective 1, PP, PWA, and PCA with 1% kaolin clay compounds were prepared through a melt compounding method by using internal mixer. Then, PP, PWA, PCA compounds were pressed by hot press at 180 degrees Celsius. The physical properties were tested, such as specific gravity by according to ASTM B792 by using electronic densimeter, density according to ASTM D1895 by electronic densimeter, and then the mechanical properties were also being tested, such as hardness according to ASTM D2240 by using durometer Shaw D hardness tester, tensile strength according to ASTM D638 by using UTeM. And then the second scope will be according to Objective 2. Morphological analysis by using SEM, compositional analysis by using FDIR, structural analysis by using XRD. For the methodology, the first step is preparation of PWA via water-assisted melt compounding using internal mixer. Next, the aggregate will be filled into the mold and then the hot press can be proceeded. After the dock bond has been done, the testing of physical properties, which is density, specific gravity, and mechanical properties, which is hardness and tensile strength, can be tested. The physical and mechanical properties will be supported by morphological analysis, compositional analysis, and structural analysis. Design of experiment. Virgin PP is a pure polypropylene aggregate. PWA, plastic waste aggregates, is recycled polypropylene aggregates. PCA, plastic composite aggregate, is recycled polypropylene that has been mixed with 1 pph of kaolin clay. Results and discussion for physical properties. For the density and specific gravity, the results show PCA, which is 0.920 gram per centimeter cubic, has the highest density among PP and PWA. Adding filler loading of 1 pph kaolin clay for sample PCA increases the composite density. A more uniform distribution of kaolin particles in the composites is indicated by the increase in PCA density. Results and discussion for mechanical properties. Hardness. It demonstrated that PP had the highest hardness compared to the other sample. The factor that made PP had the highest hardness because the PP was still a virgin aggregate, while PWA and PCA had undergone many processes to form the aggregates, as the PWA and PCA were the recycled polypropylene. Besides, since the PP was manufactured by different company, the parameters of producing the aggregates also different, that resulting the hardness result higher. PCA with 65.2 Shor-D has a marginally higher hardness than PWA. PCA increases about 2% of hardness. Kaolin acts as a filler while the metric is being filled in. Anuar 2017 said an increase in hardness and concentrated stress are produced when kaolin is added to a thermoplastic mixture. Tensile strength. Increasing PCA tensile strength is about 1.5% rather than PWA. Nga 2018 said the filler distribution on the polypropylene composite is what causes the increase in tensile strength. Based on the previous study from Etafar 2011, the tensile properties increase if the clay filler is increased, but the percentage must be not too much. The optimum percentage is 3 wet percent and 5 wet percent. Tensile modulus. Tensile modulus shows a similar pattern from the result obtained for tensile strength. PCA has slightly higher modulus compared to the PWA. The stiffness of PCA has been enhanced by the kaolin clay. Nurul 2013 said higher rigid filler content increased the Young's modulus significantly. Results and discussion for the analysis. The first one is FTIR analysis. Functional group is divided into 4 zones. Although there is no changes in peak for CH in zone 2 and CH2 in zone 3, but the intensity is increasing for PCA. Prabowo 2017 said the rise in intensity shows an increase in the crystallinity of the filler. PCA has the highest peak of OH in zone 1, which is 3,548 cm, indicate the stretching. The particular spectrum at zone 4 of CC for PCA similarly has the largest peak, which is 1,259 cm. Bending does occur. Prabowo 2017 said the spectrum at the CC bending peak, which forms the core of polypropylene. Another FTIR analysis. According to Tyranny 2012, SiO, which is silicon monoxide, shows its peak at 470, 538, 1009, 1032 cm for kaolin clay. PCA does show almost similar peak that PP and PWA does not showing any, which is for SiO is at 471, 524, 932, and 1035 cm. The intensity of the SiO peaks of the PCA is low due to the percentage of kaolin clay in PCA is only 1 pph. Secondly is XRD analysis. PCA has shown new peak at 13.197 degree and 25.7413 degree, which is a characteristic reflection of the kaolin particles. According to Tyranny 2012, kaolin peak is at 12.5, 25, 38, and 62 degree. New peak is low. 1 pph of kaolin clay has a little impact on the polypropylene matrix crystal structure. A broad peak on PCA with 1 pph of kaolin clay shows that the filler was distributed and exfoliated. Crystallinity of the PCA decreases due to a decrease in the degree of coherent layer stacking. The third one is SEM analysis. The left figure shows the fracture of PCA and the right figure shows PWA fracture. PCA shows that the surface is way rougher than PWA. According to Etafar 2011, the surface will become rougher when the polymer is mixed with clay. Rougher texture demonstrated that polypropylene and kaolin clay interact well. Compared with PCA, PWA shows that there are prominent voids cause low mechanical properties. PCA crack was small, continuous, and there was no gap between the cracks. Thus, PCA shows a good amount of bonding, resulting greater tensile strength. Conclusions. It has proven that PCA with 1 ppH kaolin clay reinforced plastic waste aggregate has increased the physical properties in terms of density and specific gravity. Besides, the mechanical properties in terms of hardness and tensile strength also has improved. The improvement can only slightly be seen as the percentage of filler is low. Compositional characteristics. New chemical composition has been found, which is silicon monoxide for PCA. Structural characteristic. By adding 1 ppH kaolin clay, the crystallinity decreases. Morphological characteristics. PCA with 1 ppH of kaolin clay fracture structure does not show prominent void and has rougher surface compared to PWA. For the recommendations, may study to further support the case for an improvement in mechanical properties like flexural and shear of plastic waste aggregates. May study the hot press parameters for plastic waste aggregates to figure out the optimal parameters for the fabrication of plastic waste aggregates. Increase the selection of kaolin clay ppH reinforced plastic waste aggregates for improved and more precise results. May study the needs to incorporate various types of plastic waste aggregates like polyethylene along with the same quantity of ppH kaolin clay. Sustainability element. Serve society by developing an improved product using plastic waste materials. Concrete will become lighter by using plastic waste as an aggregate, which is preferred in many construction due to its improved tensile strength and hardness, but low cost. Consequently, it reduces the need for raw materials and produces a greener building. And the last one, the cost of transportation can be reduced because of its lightweight. Resultantly, fuel consumption could be drastically cut, lowering carbon dioxide and carbon monoxide emissions. These are the references from this presentation. Thank you so much for your time.